Welcome to Chapter 5 of Cypress Academy, WICED Wi-Fi 101. In this chapter, we will talk about the TCP/IP networking stack, fundamentals of IP networks, and how to configure a WICED device to connect to the network. Complex systems are often managed by dividing them up into layers using hierarchy. Networking has exactly that same problem. It's complicated. And to manage the complexity, the TCP/IP networking stack was created as a hierarchical system for reliably communicating over multiple mediums, such as Wi-Fi and Internet. Each layer of the stack isolates the user of that layer from the complexity of the layer below it and simplifies the communication for the layer above it. Each layer of the stack has a well-defined input and output from the layers below it. Moreover, each layer has a well-defined protocol data unit. The PDU is the atomic unit of data for each given layer. In the case of TCP/IP, the layers are typically defined as Layer 1 is the physical layer. In the case of Wi-Fi, the interface at the bottom is radio waves, and the interface above it is a stream of bits, ones and zero. This is a place where Cypress WICED radios excel. Layer 2 is the data link layer. It takes bits from the physical layer and turns them into frames, or vice versa. Frames are the atomic unit of transmission for the network. Layer 3 is the IP layer. It takes frames and turns them into packets, which are routable anywhere on the great wide world of the internet. The IP layer deals with the addressing and routing of packets. Layer 4 is the transport layer. It either uses TCP for reliable, ordered, and error-checked streams of bytes, or it uses UDP for an unreliable, connectionless datagram flow. Think of TCP as a pipe between computers or as a phone call, while UDP is like dropping letters in the mail. They may not get there, certainly they may not get there in the same order, or they may not arrive at all. Layer 5 is the application layer. It will take segments or datagrams and turn them into the appropriate data depending on the application. If this is your first time looking at this picture, the whole thing looks a bit complicated, but you really shouldn't despair, as the networking stack is built into WICED and it manages most of this complexity for you. You're able to dig in and find things as you need them and learn as you go. A Wi-Fi connection has two ends: the station, such as an IoT device, and the access point, such as a wireless router. For a station to connect to an access point, it needs to know the SSID, the band, which is either 2.4 or 5 gigahertz, the encryption scheme, and the network key, meaning the password. The SSID is the name of the network and is composed of 0 to 32 bytes. The name doesn't need to be ASCII, but it typically is. Since the SSID can use any byte values, the name is inherently case sensitive. There are also different 802.11 modulation schemes, such as A, B, G, N, AC, or AX, all things that come from Cypress, and channel numbers, which are region-specific. However, if you are connecting to an access point from a station using WICED, none of that matters, since the WICED SDK takes care of it for you. It handles all of that complexity so you can focus on what your application is trying to do. Wi-Fi networks commonly use encryption. The network can either be open, unencrypted, WEP, which is the old encryption scheme, WPA, and now WPA2. WPA2 is by far the most commonly used scheme today and is the most secure. There are two versions of WPA2: personal or pre-shared key, and enterprise. Pre-shared key uses a password to encrypt the data. This is secure, But because everyone uses the same password, this can be very difficult to manage for large groups of users. For that reason, corporate networks typically use WPA2 Enterprise. This involves using a radius server to authenticate each station individually. The Wi-Fi Media Access Control Address is a 48-bit unique number comprised of an organizationally unique ID, which is assigned by the IEEE per manufacturer, and a station ID. Every Wi-Fi device on the planet has a different MAC address. These MAC addresses are only used locally in the Wi-Fi network, and as the information is passed on to other parts of the network, it's removed. The data link layer addresses each frame sent out by the Wi-Fi radio with a source and destination MAC address. Devices on the network pass frames to higher levels of the stack that are addressed to them. In order for packets to go to other IP addresses in the network, the data link layer needs to figure out the MAC address of a particular IP address. This is done with Address Resolution Protocol, or ARP. Each device on the network maintains a table that maps MAC addresses to IP addresses. Whenever a device has a frame to send to an IP address that it doesn't know the MAC address of, it sends out a broadcast ARP request. If the device at the unknown address is on the local network, it will respond with its own MAC address. If not, the router that's on your network will respond with its MAC address, and the router, will handle the task of getting those packets to the right place. I always thought this scheme was super clever. The internet, or cloud, is a mesh of these interconnected IP networks. All devices have a legal IP address and belong to a local network. Routers connect the local networks to remote networks by forwarding IP packets from the local network to the correct next network. The exact details of this are beyond the scope of this class, but the good news is, once again, you don't need to know the details because it's all handled for you automatically by WICED. There are two IP address schemes in the world, IPv4 and IPv6. WICED supports both of them. IPv4 addresses are 32-bit numbers, usually expressed as 4 bytes, such as 192.168.15.7. The first N bits are the network address, while the last 32 minus N bits are the client address. A net mask defines how many bits are the network address and how many bits are the client address. For IoT devices, the IP address is usually assigned by a dynamic host control protocol server. DHCP is integrated into WICED and handles the exchange of IP addresses automatically for both the servers and the clients. That's the basics of Wi-Fi networking. In the next video, we'll talk about how to use the WICED SDK to configure your IoT device to connect to the network. As always, you can post your comments and questions in our Wi-Fi developer community. You're also welcome to email me at alan_hawes@cypress.com or tweet me at AskIoTExpert. Thank you.